Hello and welcome back to the Ignite Hybrid Cloud series on Tanzu Mission Control for solution providers. In this module, we're going to take a look at using Tanzu Mission Control to enforce global policy management across our entire fleet of Kubernetes clusters. So this allows our operation teams to kind of lay down security best practices across their Kubernetes infrastructure, as well as giving the developer teams more control over how they secure their workspaces and namespaces. So TMC has various policies that can be applied to organizations, cluster groups, and workspaces, and even namespaces. So some of these policies can be applied to cluster groups by IT and operation teams, since these are usually cluster-wide configurations that the policy will change, like access control, so what groups can access what clusters, and on the roadmap, pod security policies, so allowing a operations team to lay down kind of security guardrails, so to speak, for their entire kind of managed Kubernetes infrastructure. A few of these policies, like network policy as well as image access policies, are going to be applied at the workspace or namespace level, and these will primarily be used by the application teams. So application teams can decide how they secure their namespaces and workloads and have the ability via TMC to lay down these policies on their workspaces or even individual namespaces. So IT teams will use cluster-wide policies to define some ground rules or guardrails for their developers, and then the application teams have more control for how their applications are secured and deployed via setting policy at the workspace or namespace level. So the first policy we're going to look at is specifying an image policy. So our developer teams have access to set container image policies to allow or disallow certain images to be pulled from certain registries. So if you look at our example on the slide today, we have an application group that has decided they don't want any images pulled from the public Docker Hub repo because of security concerns. They do have a private harbor registry that they pull images from, so they allow images to run in their namespaces as part of their cluster groups or workspaces. So it gives them control over what types of workloads are running in their cluster. If we have a look at network policies, which we'll demo after the slides, this allows our application teams to decide how traffic enters and exits their workloads. They can set down kind of default deny all policies across their entire workspace to secure their workloads, and then use labels on their Kubernetes workloads to create access for certain types of workloads. So for instance, in the example, in the demo, we have an application that has a service tag for a certain service name, and when we create our allow all for pod network policy, we pass that label along to TMC, which will allow TMC to lay down the network policies on the Kubernetes cluster to allow ingress traffic just for those specific apps that have that label, while still blocking traffic for other workloads running in the namespace. So the developers have access over applying these policies to their workspace if they have the workspace admin privilege. So they have kind of complete control over their workspaces, and then obviously their namespaces as part of that workspace as well. So on the roadmap, we're also looking at pod security policies being enforced via TMC as well. So if you look at the example for today, normally containers are architected in a way that they can run on a host operating system or node operating system and have access to underlying resources. So this usually happens when the container running in a pod in a node has privilege mode enabled. So this means that an app running in the container can listen to the loopback interface of the host or mount a volume in the root file system to read data, which is not really secure, so to speak, does not follow security best practices. So the vision is TMC will allow our ops teams to lay down a pod security policy that will prevent these things from happening. So prevent a pod or a container from mounting the root file system or binding to the host network or mounting host volumes. So the operation teams can make the decision about how these security policies are laid down, and they can apply them to clusters, individual clusters, cluster groups, or even across the entire organization. So that concludes the slides. Let's hop over to the TMC web UI and see a demo of the network policy in action. So we're back in the TMC portal, and I'm actually logged in as my developer, so I don't have kind of admin access to the environment. I have access to my 3 clusters in my cluster group. So we're going to click on the policy tab and have a look at network policy. And as you see, I have unprivileged status, so I'm getting some nasty grams on some of these resources. But I have workspace admin privilege on the Ignite workspace. So that allows me to set network policies on the workspace, and then namespaces within the workspace. So I've got a Yelp app deployed, which is a restaurant review app deployed in my cluster, and it's exposed to the public internet via a load balancer service type. So we grab the public IP address and put that into the browser, and we can access our application. So I can vote for my favorite restaurant here. Other users, I can pass this along, they can vote for it. But any workload running in my cluster is accessible now, so it's a bit of an insecure policy. So I'm going to lay down a deny all network policy on top of my workspace. So any namespace in this workspace automatically gets a network policy deployed that denies all traffic to the resources running in the namespace. So I'm going to add that policy and hop back over to the terminal and check to see that we have it implemented in our cluster on the namespace. So I have my context set to my Ignite namespace. So all I have to do is check kubectl get network policies, and that will eventually show us after the TMC agents do their work and sync, that our Ignite deny all policy is actually applied to the cluster. So now if we go back to the web UI and refresh the page, the UI itself is actually still cached in the ELB, in the load balancer, but I can't interact with the services. I can't vote. None of the votes are tallied. But this is not exactly what we want. But now we're secure in that we can't access our workloads, but we want to be able to access some. So I've labeled my Yelp app with the service equals Yelp key value pair. And so that allows me to go back into TMC and set an allow policy, allow traffic to all pods with a certain label. So in my case, will be service equals Yelp. So that will allow access to my load balancer service, so my external users can get access to my restaurant review site. If I run back to the command line, I can now again check the network policies in the namespace to see that the TMC agents have synced with the portal and have pulled down my Ignite allow Yelp namespace with service equals Yelp as the pod selector. So if I hop back over to the UI and refresh the page, now I can vote for my favorite restaurants again, and my external users can access my site without having access to other applications in my workspaces or namespace. So that concludes our session on global access and security policy in TMC, as well as our Ignite Hybrid Cloud series on Tanzu Mission Control for solution providers. Thank you.